Hey, my name is Jonathan Helm, and in this video I'll show you how to do a two-way ANOVA in R. So this will just build from the previous video. So I'll start by using the same dataset, the salary dataset. So I'll go ahead and I'll read that dataset into R. Okay, and it's always a good idea to take a look at the first 6 rows of the data, just to make sure that the data are writing correctly. You can do that using the head function. Looks like everything's okay. So for this one, I'm going to look at the main effects of both biological sex and department, as well as the two-way interaction between the two. Now, right now, 2 variables that I'd like to use are female and department, and those are both numeric variables. So I need to change each of them into a categorical predictor. And so I can change them to a categorical predictor using the factor function. So I'll change female to categorical predictor. So I'll create a new variable and I'll call this one biosex for biological sex, for sex assigned at birth. And I'll say factor, and then in parens I'll put data $female. We have the levels equal to 0 and 1, and the labels will be equal to male, right? Male is 0, and 1 is female. Okay, so just a couple of things to note about the factor function. So everything is inside the factor function, right? This is closed out here. Okay, so we're going to take the variable named female inside the data set called data. We're going to say that it's categorical and that it has certain values for levels, so it has just 0s and 1s. And we'd like to create a new variable that has the labels male for 0 and female for 1. Okay. So I'll highlight and run that code. And I'll take a look at the top of the data set again, just to see if it created that variable for me. You can see now we have a new variable inside our data set called biosex for biological sex. We can see that if female is equal to 1, then biosex is equal to female. And if the variable female is equal to 0, variable biosex is equal to male. Right, so this is reproduced what we wanted. And so now in the future, if we wanted to use biological sex as a predictor in our analysis of variance, R knows that biosex is a categorical variable. Okay, so let's do the same thing for department. Change department to categorical predictor using the factor function. So I'll just say data $department factor. Okay, and I need to enter the variable that I'd like to change, so department. The levels for this one are 1, 2, or 3. Okay, and 1 corresponds to psychology, 2 to sociology, and 3 to economics. So I have labels, psychology. I'm going to just hit enter so I can put all of this. I'll move the syntax over a little bit and make this a little bit larger. So psychology, sociology, and economics. Okay, so it's really the same process or the same setup that we had for creating the new variable biological sex up here. Okay, now we're just doing it for the variable called department. We'll make a new variable called department factor. That will be the same as the variable department in our data set called data. That variable department right now has values 1, 2, and 3. Okay, and 1 is going to correspond to psychology, 2 will correspond to sociology, and 3 will correspond to economics. Okay, so I'll highlight and I'll run that code. Let's take a look at the top of my data set again. And so now we have this new variable in our data set called department factor. And all it's doing is just changing this variable department to be a categorical variable with labels. So 2 is sociology, 1 is psychology, and 3 is economics. Okay, so it looks like we've been able to convert them okay. So now what I'd like to do is run two-way analysis of variance, predicting salary from biological sex, department, and the two-way interaction between biological sex and department. Okay, so what it'll do is, remember, we always have to start using this options command. So it's options, and then I type the word contrast. Oops. And I set that equal to a vector. There's 2 arguments. The first one is contour.sum, and the second one is contour.poly. Right, and this makes sure that we're testing for main and interaction effects in the normal way that we test for it in ANOVA. Remember that I'm also going to need to use the capital ANOVA function from the car package, so I'll just open up the car package. Okay. So now we'll fit the ANOVA model. Okay, so I'll do model.01 is equal to a linear model where I'm going to predict salary. I'll have an intercept. I'll have the main effect for biological sex. I'll have the main effect for department. And then the last one will be this two-way interaction, which you can specify using a colon. Right, so the two-way interaction between biological sex and department will be specified by adding a colon between them. Okay, so I have one main effect for biological sex, one main effect for department. Remember, we're using department factor here because that's our categorical variable. And then the interaction between biological sex and department factor. Oops. Okay, so these variables are in the data set called data. And I'm going to add one more option. This is na.action equals na exclude, which is to say that if you run into any missing values, to go ahead and remove those from the analysis. I'll highlight and I'll run my code. And then we have my capital ANOVA function. And we insert model.01. We say type is equal to 3. Don't forget this part. This part's important. Okay, and then we'll highlight, run this. And we get our output. Okay, so the part here for biosex, this is indicating the main effect for biological sex. And so we see that this is testing for average, the marginal means for males versus females for salary. We see that we don't find that those are significantly different from one another using the criterion of 0.05 for our cutoff. For department factor, right, we're looking to see if the marginal means for salary and psychology versus sociology versus economics, if any of those marginal means are different from one another. P-value is not less than 0.05, so we don't reach our cutoff, and we can't conclude that those are significantly different. And then the last one does the interaction between biological sex and department, right, and that one the same. So in this particular example, nothing seems very interesting going on, but just know that we're looking at these, right, for each of the main effects. So biosex is the main effect for biological sex, department factor is the main effect for department, and then this is the two-way interaction between the two. Okay, so that's all I got. I hope you enjoyed the video, and thank you so much for watching.